Okay, this is where the project starts. So we're maintaining this depth. It siphons out of that hose back into here where there's a pump. The pump is powered by four AAA batteries. I have 4 relays there, but I'm only using one of them. I have an Arduino Nano with the program on it. The Nano communicates with my Arduino right here. I have a few variables: the distance from the top, and we calculate the pump depth, the depth at which we want the pump to kick on. We calculate the depth within the tank. We adjust the pump on depth using a potentiometer. So we're going to read from a analog pin 2. We're going to read from there with the standard delay time of half a second. This is the code for our ultrasonic sensor. Pump on distance. The tank is 7.5 inches tall, and then the potentiometer reads from 0 to 5, so you can set it to a 1/2 inch depth, or 5.5 inches, which is 2 inches from the top. When the actual depth is less than the pump on depth, you kick on the pump. It stays on until we've reached 1.25 inches from the top. This information is communicated through the serial monitor. It's outputted right here, so you have your distance, your pump on depth, and your actual depth. So right now, when the actual depth drops to a 1/2 inch, that's when the pump will kick on. And it's falling. Show you over here our current depths. So the tank depth is 1.3. It's modeled right here. 1.3, it's dropping. Like we said, once it gets to a 1/2 inch, you'll hear the pump kick on. The tank was originally standing on 12-inch dowels, which is why we have 12 inches here. The tank is 7 inches tall, 3.5 inch radius, 3.5 inch wide radius for this tank. 3.25 usable inches. You consider wall thickness. Over here we calculate the elevation in inches, the available volume in cubic inches, the tank depth, currently at 1 inch and dropping. The head pressure is 2.48 psi. So here we'll watch this depth right here, 0.9, 0.7. It's gonna kick on soon. Okay, my ultrasonic sensor, as the tank level drops, the measurement is now off by about a 1/2 inch, but it's more accurate when the tank is full. It may not siphon to the desired depth because that's not much elevation difference when you consider friction in the tube. Oh, it did. Okay, so now it's on and now it's filling, so we can scroll back through our data here if we wanted to. Let's see what reading it actually got. Pump, see, yeah, it did read 0.5 for quite some time. I'm not showing all the decimals, so maybe that's why it didn't. Oh, here we had a bad reading. Or no, 0.08. So what's neat is you can adjust this pump on depth. Right now it's set at a 1/2 inch. But we'll come over here and turn this potentiometer, and you'll see that this pump on depth, I can adjust that. So now I'll set it to 2 inches because it's definitely below 2 inches. So yeah, now the pump kicks on. And did we see we got a random reading of 3.7, which caused it to glitch there for a second. But now we're filling. Tank's at 1.8 inches. Over here, water tower 1.6. Okay, so it's getting a little better. Over here, we're showing. Yeah, you can see that my ultrasonic sensor is maybe not the best way to measure the depth in the tank. Maybe we could use a float on a rod or something. That's all I got for now. That's all I got. Thank you for watching. Thanks for watching.